Welcome. I am Ms. Howrington at Research Triangle High School, and we are talking about the birth of stars, because a star is born. So, the first thing that we need to talk about is stellar nebulas. So, a stellar nebula is a really big cloud of gas, mainly hydrogen, because it's the most abundant element in the universe, and dust. So we see lots and lots of little particles floating around, and the attractive force in the universe, gravity, is attracting all of these little gas particles towards each other. And so as these gas particles get attracted towards each other, they start colliding, and then hydrogen atoms will start to stick together or fuse and create helium and release energy. And so now, once fusion starts happening, we have a main sequence star. So, in a main sequence star, if an average amount of gas and dust got pulled together, we would end up with an average star, like our sun, oopsies, where we have fusion going on in the center, and gravity is pulling the core together, but all that energy being released from fusion is pushing out. Or if a huge amount of gas and dust got pulled together, then you end up with a massive star. There is so much fusion going on in the center of a massive star so fast that it is ridiculously hot. It is blue hot. And so it comes out blue in color. This picture is not drawn to scale at all. If it was drawn to scale, our sun would probably be like this big compared to that massive star. So our sun is really tiny compared to massive stars. All right, so eventually all of that hydrogen inside of the star will be fused together into helium. And so once the star starts to run out of hydrogen, it becomes either a red giant or a red supergiant. So the red giant is if it was an average star, and the red supergiant is if it was a massive star. And so in red giant stars, we have our core collapsing on itself under its own mass, because the helium inside the star is starting to fuse together into even heavier elements, mostly carbon and oxygen, but some other stuff too. And so, yeah, so we have our helium fusing together into carbon and oxygen, which are even heavier elements, and so that extra mass in the center of the star brings all of the particles in on itself, and they're collapsing, but the outside edges of the star are expanding. That's what makes it the giant or the supergiant. All right, and so that same process is continuing to happen until the core collapses. So if it was an average star, then we would get a planetary nebula. The core would collapse, and the outer layers would continue to float off into space. This is not a very good drawing of it, but you can look up a picture. They're very beautiful. And if it was a massive star, then the core gets so incredibly massive, it has so much mass, that it violently collapses on itself, and it causes an explosion. So your core, all the particles are attracted to each other, and they violently collapse and then rebound out, and you get a supernova, which is also very pretty, and my picture does it no justice. And then once those outer layers of the planetary nebula or supernova start to float off, then you can get, if it was an average star, then maybe after the planetary nebula outside edges float off, you end up with a white dwarf, which might eventually, once it stops doing fusion at all, transform into a black dwarf. But that takes a really long time, and we've never actually seen it happen, I don't think. I could be wrong on that, though. And if it was a massive star, like a regular-sized massive star, then it could become a neutron star, where it has a super-de-duper dense core. So when I was doing research, NASA said that if the center of a neutron star was the size of a sugar cube, then it would weigh 1 billion tons. That is really dense. And so there's not a whole lot of fusion going on in here, so they're emitting radio waves, which are very long, very low energy waves. So they're kind of hard for us to detect out in space. Or if it was a huge, supermassive star, really massive star, then we might get a black hole, which is when there is so much matter crammed into one tiny space that the gravity is so strong that not even light can escape. And so we can't really see these out in space, but scientists think that they're there because of the way that other things near them behave. So once they get near the event horizon at the edge of the black hole, you can kind of see like light being sucked in and not being ever let out. So now you know how not only a star is born, but also how a star dies. All right, we will discuss this more in class, and I will see you there.